Students, how are you? In today's lesson, we're going to talk about longitudinal wave, which is the second type of mechanical wave after transverse wave. Now to begin, let us define what is longitudinal wave. We have so many definitions of longitudinal wave, but for me, I've just chosen two for you. The first definition is saying longitudinal wave is the kind of wave whose matter vibrates parallelly to the direction of a wave. That means the direction of matter and the direction of wave is parallel to each other. That is the first meaning of longitudinal wave. The second meaning, which is stated in a different way with the first one, but meaning the same, is saying a longitudinal wave is the kind of wave whose matter direction is the same as wave direction. Matter direction is the same as wave direction. The first one, matter direction, is parallel to wave direction. Now to understand what does this definition tell us, let us consider the illustration which illustrates about longitudinal waves. Here is the illustration. This illustration is explain about one of the kind of longitudinal waves, where now here we have particles. Now the direction of these particles are the ones which explain about longitudinal wave. Assume this is the source of the particles vibrations. When you look on this diagram, you will find that we have two series of particle distributions which are different. In the first region you can see the particles are close to each other. The second region, the particles are far away from each other. And again, the third region, the repetition of the first repeats, and the last one is the repetition of the second. Therefore, this illustration shows that here there is a series of different arrangement of particles. Now, in longitudinal waves, we have the following. These are the particles. This region here is called compression, given by letter C. In compressions, the wave direction, the particle direction is towards where it is from. That means it is towards its mean position. It's towards to the source. Therefore, the direction of particles here is this way. Now, where would be the direction of wave? From the definition is saying the longitudinal wave, particle direction and wave direction is the same. Obvious, the wave direction will be in the same direction with the direction of the particles. Look, particle direction is towards the mean position or towards the source. The wave direction is also in the same direction with particle direction. Another feature here is this one here, which is layer function, which is given by R. Layer function occurs when the particles move away from the source. Now the particles direction will be this way. Again, from the definition is saying in a longitudinal wave, particle direction and the wave direction is the same. Automatically, under layer function, the wave direction will go the same direction as the direction of the particle. But also again here, again under compression, we have said its direction is to the medium or to the source. Now the direction of this part here will be this way, but the direction of the wave will be in the same direction with the direction of the particle. Therefore, the wave will move this way. Again here, this is layer functions, where the direction is away from the mean position, and now the wave will follow the same chain where the direction will be this way. Therefore here, this is direction of particle's direction, but here this is wave directions. What do you see? Here from these explanations, it tells us that in longitudinal wave, particle direction and wave direction is the same. Therefore, longitudinal wave occurs when there is back and forth movement of the particles. That means right and left movement of the particles in the medium. The particles move away and they come again to position, move away and come again to position. By doing so, we have two features which will be formed. We have compression, which is formed when the particle is coming back. We have rear function, which is formed when the particle is moving away. Therefore, these are what we can explain. This is what explains about longitudinal waves. Now, from this diagram here, we can see that under longitudinal waves, we have two features. We have two features here. The longitudinal wave features, we have two. The first feature is called compression, which is this one. We have two features which are compressions and rear function. We have two features under longitudinal wave: compression and rear functions. Now we can define these features. What is compressions and what is rear function? From this diagram here, you can see compression is the region in longitudinal waves where particles are close to each other, but rear function is the region where particles are far away from each other. Now let us start with compressions. Compression, particles are closely packed together, as you can see here. Why are they closely packed together? It's because the particles return to the equilibrium position. When the particles return to the equilibrium position, they become closer to each other. Now, what is the effect now of the particles to become closer to each other? When the particles become closer to each other, like you can see here, when the particles become closer to each other, like you can see here, the particles are very close to each other. When the particles become close to each other, the following features can occur. First of all, friction increases. Here, friction is high. Here, volume is decreased. When the particles are close to each other, volume decreases. Now, what happens when volume decreases? Friction becomes high. Friction is high. Why? Because particles are close to each other. There is more collision when the particles are close to each other. What's happened when friction is high? When friction is high, I said volume decreases. Here, volume of the particle decreases. Hence, friction is high. Now, if the friction is high, pressure and density also is high. Therefore, under compression, volume decreases, friction high, pressure and density also becomes what? High. Therefore, we are saying under here, volume of the particle decreases. But if the volume of the particle decreases, friction, pressure, density increases. This is what we can talk about compressions. But another feature is layer functions. Another feature is called layer functions. Layer function is here. Now you can see what is layer function. This is the layer function I'm talking about. And the layer functions, you can see particles are far away from each other. This region, particles are far away from each other, or we can say the particles are rarefied. How the particle can be rarefied? This is simply when the particles go away from its positions. When the particles go away, if this is the position, it's the positions. If this is the source of the particles, now when the particles go away, they do what? They do rarefied. Take an example of spring experiment. Take an example of spring experiment. Now, if we tie the spring here, this is the spring. Now, what's happened when we push the spring back? When we push the spring back, that means we return the spring to its positions, the size of it decreases. But what happens when the spring is pulled? When we pull the spring, we increase its length. We increase its length. Now, this is what we talk about layer function. Layer function occurs when the particles move away from its equilibrium positions. Now, when the particles moves away from its equilibrium position, we end up getting the so-called layer functions. The direction of them and the direction of wave is the same, and this is what we talk about longitudinal wave. But under layer functions, the following happen. Under layer functions, the following happen. Under layer function, you can see the space between the particles increases. Space means volume. Therefore, here, volume increases. Now, if volume increases, what's happened? If we increase the volume, we hinder the friction. Therefore, here, friction is low. Friction here is hindered, therefore is low. Friction is low because the particles are far away from each other. Therefore, under layer function, the volume of the particle increases. Not only the volume of the particle increases, the friction is low. If now the collision is low, pressure which will be exerted here is low also. Pressure is what? Low. Why? Because the collision is minimum. But pressure is low. Not only pressure is low, density here. Density is what? Is low. Why? Because density, remember my students, density is nothing but mass of volume. Now when we have high volume, automatically you have low density. Therefore, under compression, under layer function, volume is high, friction is low because particles are far away from each other. They cannot collide. There is a low possibility of colliding because they are far away from each other. Now, if friction is low, pressure, remember, pressure depends on collision. Pressure is low. Now, if pressure is low, the density also under this media is what? Is low. This is what we talk about. This is what is layer function. Therefore, under layer functions, friction, pressure, density decreases. Why? Because the volume of the particle increases. Apart from that one, we can now look in this point here. Apart from these ones, we can now go to this point here. apart from these ones, we can now go to this point here, which is saying compression. You have discussed compression and rare functions do not change the shape of the medium. The medium remained to be the same. The medium remained to be what? The same. But what changes there is pressure and density. Under rare function, the shape of medium remained to be what? The same. But what is changing is pressure and what? And density. Now, what can we conclude here? Conclusion is, then longitudinal wave do not need elastic of shape, because the shape remain to be what? The same. Under longitudinal wave, there is the formation of compression, rare functions. Compression, rare functions. We don't disturb the shape of the medium, because under transverse wave, the shape of the medium was disturbed, because now there is the series of high pitch, low pitch, high pitch, low pitch. But here, the shape of the medium remain to be what? The same. But what is affected is pressure of the medium, and the density of the medium are the ones which changes, nor the shape. Now, if pressure and density are the ones which changes, what can we conclude? We can now conclude that longitudinal wave is a wave which can take place in all three medium, which are solid, liquid, and gas. Longitudinal wave can take place in solid, because in solid there is change in pressure, there is change in what? In density and pressure. In liquid, it's the same. There is pressure, change, and density. In gases, also, there is change in pressure and what? In density. Therefore, longitudinal wave can take place in all three media. Due to this, sometimes longitudinal wave is called pressure wave. We can call longitudinal wave as a pressure wave because its sections, which is compression rare function, are experienced different pressures. Some is low pressure, but the other area is high pressure. Hope at that point you have well understood. Let us have a short break.